So, Honors Algebra, today we are going to work on Lesson 97. You will find that in your book on page 405. There's a lot of information there. I'd love for you to read it, which you should be doing every day, just because I'm trying to simplify and streamline and just teach the gist of the lesson, but you do want to read through it. Your book is excellent with explaining things, so definitely read through each day. So the Pythagorean theorem, we talked about it last year, so it shouldn't be too difficult. We know that the two rays that form the angle, the right angle, are called the legs. The side opposite is the hypotenuse. They're often labeled A, B, and C because of the theorem, okay? So if we squared A and added it to the square of B, we'd have the area of C squared. And someone created a nice little poster for me last year. Get that in the right spot, and you guys can see this lovely diagram that's quite helpful. Great. So let us do the first example, which is on page 407, and we are going to plug in different values here. All right, so let's say that with example 1, we have A and 4 and 5. All right, so according to the theorem, leg squared plus leg squared is hypotenuse squared. So A squared plus 16 equals 25. So algebraically then, A squared, subtract 16 on both sides, get 9. And so the square root of A squared would be A, and the square root of 9 is 3 or negative 3. But we know we're dealing with measurements, and we don't have negative measurements, so we are just going to take the principal square root there. All right, and that's reasonable, right? Your hypotenuse should always be your longest side. So there we have it. Now let's do a different example. Let's kind of move things around a little bit. Okay, let's do example 2, which has the hypotenuse, I believe, is what we're looking for. And this is 4, and this is 5, okay? So, leg squared plus leg squared is hypotenuse squared. So 16 plus 25 is p squared, and so 41 is p squared. So I take the square root of both sides. Well, radical 41 has no perfect square factors. It's not a perfect square itself. So I'm just going to leave it radical 41. Unless they tell me to approximate, I can leave it as a radical. Okay, again, the positive. Okay, so looking at the next example, we have K, and we have 5, and we have radical 61. All right, so we're going to plug these into the formula. K squared, leg squared, plus leg squared, 5 squared, equals hypotenuse squared. All right, so K squared plus 25 equals, okay, what happens when I square a radical? The radicand comes out. If you multiplied 61 by 61, not sure what you get, but it's going to be the square. I think it's 2, let's see, what is it? 61 times 61. Okay, 3721, which is 61 when we take it out of the radical. There we go. Okay, so K squared then would be 61, take away 25, which is 36. And so K, taking square root of both sides, would be 6. All right? So if you look at the other examples, you will follow along. I believe on 97.4, in this one, if you look at example 97.4, you have 8 12, and you're looking for m. Okay, so when we have 12 squared plus 8 squared is m squared. This is 144 plus 64 is m squared. Now this is 208. So when you take the square root of both sides, you'll get m. Now radical 208 can simplify, okay? 208 is actually 16 times 13. And so the square root of 16 is 4, radical 13. You do not have to approximate these with a calculator, but you do need to simplify if there's a perfect square factor that can go into your radicand. Okay, now the other part of the lesson is to remember the Pythagorean triples. And again, I believe we talked about this last year, so it shouldn't be an issue. 3, 4, 5, and any multiple of that. So of course, 6, 8, 10, and 9, 12, 15, 30, 40, 50, right? So any multiple of the triples would be a fit the Pythagorean theorem without having radicals, okay? There's 5, 12, 13, and of course any multiple of that. So 10, 24, 26. And another one that we popularly see is 8, 15, 17. Okay? So when you see those, you want to quickly recognize what the missing side is so you don't have to apply the theorem. It's like quickly comes to mind, right? So in other words, they're going to have an exercise maybe like this, and it'll be 8, 15, and x. So yeah, you could apply the theorem, but if you know the triples, you know, oh, x is 17. All right, so let's go ahead and do the practice, and then we'll let you go with the lesson. So for practice A, P is radical 61. Okay, when you take 5 squared plus 6 squared, you're going to get 25 plus 36, which is radical 61. You can't take that out of the square root. All right, for B, I'm going to go ahead and show you this one. So we have F and 5, and I'm drawing beautiful diagrams here. Sorry about that. Okay, F squared then plus 25 equals 15 squared, which is 225. So F squared would be 200. So we take the square root of both sides. This can be simplified to 100 times 2. Of course, 100, the square root of 100 is 10, but radical 2 stays underneath. So you would want to simplify that. All right, for C, they just want you to recognize the triples. So that answer is 5. And for D, R is 8. All right, so you can check RenWeb to see your assignment. Have a great day.